Hello, my name is Robert Jesus Gonzalez Diaz, and the name of this project is Development of Sandwich Composite Cars by 3D printing based on filament with carbon materials reinforcement. First one, we have the abstract, uh, the need of diversifying the material available for sandwich type composite cars is increasing due to the search for great efficiency and adaptability to various situations and needs. Shootout and his team determined by uh, that as honeycomb core density increase, flexural strength, stiffness, and fracture toughness increase. Although several factors still need to be studied to determine a generalized methods for optimizing core designs and the variability of the materials. Thus, in these investigations, three commercial filaments based on PLA were selected to obtain with carbon reinforcement, which contain carbon fiber and carbon nanotubes, and the test only PLA as a reference. The research consists in the study of the printing parameters considering two core design with complex geometric structures. The first one, honeycomb and auxetic hexagon honeycomb, and later the characterization of the base material by DSS-C, FTIR, mechanical evaluation of cars, torque bending, and traction test. Okay. Methodology. We had the first material we chosen in online market. The purchased material were pure PLA, filament, carbon fiber reinforcement, PLA, filament, and carbon nanotube reinforced PLA filament. Afterwards, the course of the test tube to be used was designed, in this case honeycomb and Reinhardt. Honeycomb. Next, a 3D printer was used to manufacture the specimens with the proposed designs using the purchased material. Finally, the specimens to be used to the design mechanical test were obtained. The first two are the design for tension test, and the third of is for bending test. Okay. And results. At the first, we have the dynamic mechanic analysis graphic that was made to the material with which they work. The curves obtained show the PLA reforms with carbon fiber is the most rigid material, followed by PLA with carbon nanotubes, and finally pure PLA, which is the less rigid but most flexible material. This means that carbon fiber reinforcement (PLA) has the greater ability to resist electric deformation, make it more suitable for applications that require rigidity and strength, such as the manufacture structures for mechanical components. The second graph shows tan delta. The tan delta values provide information about the mechanical properties and energy absorption capacity of the different materials. In this case, they indicate that the carbon fiber reinforced PLA has the best properties in terms of resistance to deformation and capacity to absorb impacts, followed by pure PLA and PLA reinforced with carbon nanotubes. The following is a stress strain plot which indicates that adding carbon nanotubes or carbon fiber to PLA can improve its mechanical properties, making it stronger and less flexible, depending on the shape and amount of reforms used. The values obtained by the graph were placed in the table. From this, we can understand the higher value Young's modulus implies greater stiffness and less deformability, while a lower value implies less stiffness and greater deformability. Uh, Finally, in the last image It is possible to observe microscopically how the structure remains after the fracture. You can see the torn fibers and the final contour of the structure. So, conclusion. First one, the pure pellet show that it's the most flexible material and therefore less mechanically resistant. Reinforcing with carbon nanotubes managed to increase its stress and deformation, indicating that the material becomes mechanically stronger but less flexible. Whereas reinforcing it with carbon fiber makes it extremely strong but less flexible. Second one, the conventional honeycomb has advantage in terms of impact resistance at low energy levels compared to reentrants. By comparison, at higher energies, reentrants provide greater strength under large strains because material flows into the impact region. And that will be all. Thanks for your attention. Regards.